Hello, so good morning everyone and welcome to today's class. Today happens to be day 2 of our NTC preparation class, and we're going to be looking at numeracy for today. Numeracy. Now numeracy is basically about numbers. So we're going through a lot of topics as we saw in the earlier video yesterday on the intro, the relevant topics we'll be looking at. So let's begin today's topic: introduction to numbers and numerals. Introduction to numbers and numerals. So in today's topic, the following are the areas we are going to consider. We're going to look at natural numbers, whole numbers, integers, decimal numbers, rational numbers, irrational numbers, even and odd numbers, prime and composite numbers, multiples, and then we delve into LCM, that is the least common multiple. We look at factors and we consider highest common factor, or HCF, otherwise known as the GCF, that is the greatest common factor. We will look at set of numbers, we would add Venn diagram, and if time permits, we would add also number pattern to it. These are very simple things that will not take much of our time. So let's begin. When we say natural or count number, what are they? So a natural or a count number is simply numbers that are used for counting, and they begin from 1 throughout to infinity. So we use these numbers every day in our counting. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc.
So it must be relevant.
These numbers are referred to as the count numbers. Next is to look at whole numbers. So whole numbers, whole numbers begins from 0 to infinity. So whole numbers are count numbers, a blend of count numbers, but each time around they begin from 0. So 0, 1, 2, 3, 4 to infinity are all whole numbers. Then next is integers. So integers simply contains 0, contains negative numbers as well as positive numbers. So you can see we have -3. It's actually from, so the negative continues, is to infinity when it comes to the negative side. So we have -3, -2, -1, 0, 1, 2, 3 to infinity. So a mixture of positive and negative numbers with 0 are referred to as integers. Now next we look at is decimal. So when we say a decimal is simply any number that contains the decimal point. So you can see the decimal points here. You can see decimal points here. There are lots of examples. You can say 0.007 also is a decimal. Now we have rational numbers. So rational numbers are simply numbers that can be expressed as fractions. So if a number can be expressed as a fraction, it is a rational number. Example, 1 on 2 is the same as 0.5. Likewise, with a 0.007 I just wrote can equally be written as a fraction, and that would be 7 on. Now here move 1, 2, and 3. So we have 1. Then how many zeros can we move? 1, 2, 3. If you're not seeing it clear, let me do it this way for you. Let me change my pen. So now let's jump. 1, 2, 3. It means that we need to add 3 zeros. My yellow is not so clear. Let me use the blue. So we have 1, 2, 3. Because here with the jump, so it was 1, 2, and 3. So we have 7 on 1000 as a representation of the same number, 0.007. Next we have, now irrational numbers are some numbers that can be expressed as fractions. So that is the opposite of rational numbers. Now we have even numbers. Now even numbers are simply integers that can be perfectly divisible by 2. So when a number can be perfectly divisible by 2, it means you can divide the number by 2 and there will not be a remainder. So we have 2, 4, 6, 8. Now I know there is a game that a game that ladies often play when they are young, so they say 2, 4, 6, 8. So ladies, that's very game you play. It's a game of even and odd numbers, so they try to leave a regular interval. Now next is odd number. Now odd numbers are simply numbers that cannot be perfectly divisible by 2. That means that when they are divisible, when you divide them by 2, there is always a remainder of 1, and they begin from 1, 3, 5, 7, 9, 11, etc. So it goes on to infinity. Next, we have prime numbers. So what is a prime number? Now a prime number is simply a number that has, so any number that has only 2 factors. So they have only 2 factors. They are called prime numbers, and then those 2 factors are the number 1 and the value itself. So 1 and the number itself. When the number has only 2 factors, 1 and itself, it is called a prime number. So we're looking at what is a factor. So let me just jump and come to what is a factor. So factors are simply numbers which when multiplied gives a particular result. Example, factors of 24. If you want to look for the factors of 24, it means you're looking for numbers that when you multiply would give you that particular result. That would give you 24. So in this example, let's see. 1 times 24 would give you 24. 2 times 12 would give you 24. 3 times 8 would give you 24. And 4 by 6 would give you 24. So these are the factors of 24. So now let's come back to prime numbers. So we said with the prime numbers, they are numbers that have only 2 factors. When we look at 24, 24 is not a prime number simply because it has 1, 2, 3, 4, 5, 6, 7, or 8. It has 8 factors. It means 24 is not a prime number. Example of prime numbers are, let's say, 11. Now 11 has only 2 factors. We have only 1 and 11 itself. There is no other number that can be multiplied. There is no other count number that can be multiplied to give you 11 apart from 1 and 11. So that is with that. Now there is an opposite for prime numbers, and that is called composite numbers. Let me write that here. Composite numbers. COMPOSITE. So composite numbers. Now composite numbers is the reverse of the prime numbers, and these are numbers that have more than 2 factors. So example is 24, or just look through these. The numbers left out are all composite numbers. So we have 4, we have 6, we have 8, we have 9, we have 10, we have 12, we have 15, we have 14. All these are composite because they have more than 2 factors. Next we're looking at is multiples. Now multiples are simply the results when a chosen number is multiplied by count numbers. Example, I choose the number 7. If you want to find the multiples of 7, it simply means that the results I'm going to get when I multiply count numbers by this number 7. So count numbers, you know, they begin from 1. So 7 times 1 will give you 7. 7 times 2 will give you 14. 7 times 3 will give you 21. 7 times 4 will give you 28. 7 times 5 will give you 35. In that order. So I'm sure you do remember in basic mathematics, in the early ages of your life, you were taught this very concept: 2, 1, 2, 2, 2, 4, 2, 3, 6. Now all those things are what we call multiples. So that's with it. Now in multiples, there is one thing that is relevant we need to make note of. That is the least common multiple. Now, under least common multiple, you'll be given 2 chosen numbers, 2 given numbers. So in this example, we realize we are given 6 and then 8. Now the question asks you to find the least common multiple. That is, when you take the multiples of 6, multiples of 8, which one is common in between 6 and 8? Now of those common numbers, which of them is the least of the common numbers you see? So in that case, we're going to do it this way. So take 6. What are multiples of 6? So let's go. 6, 1, 6. 6, 2, 12. 6, 3, 18. 6, 4, 24. 6, 5, 30. 6, 6, 36. 6, 7, 42. 6, 8, 48. 6, 9, 54. 6, 10, 60. Now it continues on and on and on. Since we're looking for the least common number, we should not really waste time going so far. Now let's come to 8. 8, 1, 8. 8, 2, 16. 8, 3, 24. 8, 4, 32. 8, 5, 40. 8, 8, 48. 8, 7, 56. 8, 8, 64. 8, 9, 72. 8, 10, 80. Now we have listed a few of the common numbers. It is our task to now identify which number is common and is the least. So to do this, we simply begin from the least side, that is from the extreme left. So let me choose the yellow background, or let me choose the red. So let's see, 8. Okay, let me start from 6. Now 6, do we have 6 in the 8th column? No, so 6 is out. Now let's come to 12. Do we have 12 in the 8th range? No. Let's come to 18. Do we have 18 in the range of 8? No. Let's come to 24. Do you have 24 over there? Yes. So you can see we have 24 here. We also have 24 there. So 24 is the smallest number that is common. Let's see if we can get other numbers that are common but are larger. So 30, no. 36, no. 42, no. 48, yes. 48 is there. But realize 48 is what? A larger number. It's a bigger number compared to 24. So the right answer is what? 24. So that is why we have our LCM to be 24 over here. I'm sure it makes sense to you. Alright. So we looked at factors from before. Now with our knowledge in factors, let's now consider highest common factor, or HCF. Now highest common factor is just like the LCM, the largest common number among a given set of multiples. So example, you have 24 and you have 32. Now please pardon me, let's make a correction over here. Let me cancel this. So the largest common number among a given set of factors, not multiples. So cancel that, and the right thing is factors. So factors, CTOR. Forgive me my poor writing. Alright, so that's with it. Now let's see the factors of 24 and 32. So what numbers which numbers would give us a product of 32? That is, what numbers would we multiply to get 32? And we have 1 and 32 itself. We have 2 and 16. We have 4 and 8. Now 24, we have already listed them elsewhere. Or okay, 24 we have 1 and 24. We have 2 and 12. We have 3 and 8. We have 4 and 6. So of these numbers, we're looking for the highest common factor. So highest, like LCM, we're looking for the least. So we began from what? The extreme left. Because with HFC, we're looking for the largest or the highest number. Let's begin from the extreme right. And so let's compare 32. Do you have 32 also in the 24 range? No. 16. Do you have 16 in the 24 range? No. Now let's come to 8. 8 is here and at 32. Do you have 8 in the 24 range as well? Yes. So 8 is the highest common factor between the factors of 32 and 24. That is it. Now also in today's topic, we'll be looking at a few things that are common math symbols, and then These are things we know already, so let's just brush through them. So addition or the plus sign, we have the subtraction or the minus sign, multiplication or what we call times, which is used to multiply a number to get a product of a given number. Now we have the division or the forward slash sign, which this division sign is the most common one we often use, or the right one. We have equal to or equals, we have less than, greater than, less than or equal to, and also greater than or equal to. So these math symbols are things we should just have in mind. So if you are forgetting all of these, please, please, we are reminding you, just recap all these things so that you can start the math proper. All right. So I'm going to make today's video in 2 sections. So I'd like to pause here and release a video. Thereafter, we continue with the other parts. But anyway, let's continue so that I can just make it one. So it's going to be a bit larger, but don't worry, we're going to sort it out. Okay, so next topic, sets of numbers. Sets of numbers. Now we have seen numbers in the initial slides. Now the set of numbers, one thing is very important we need to know. Let's identify what a union is and what intersection is. These are the common things that will be assessed in the exam. That's why I'm focusing on that alone. So when you say union, union simply means the list of all the values when given sets are put together. So when we are given 2 different sets and we want to put them together, you see you have found the union. And within a given set, if there is a number that is common in A and in B at the same time, or in A, B, and C at the same time, those numbers are called, if you want to find those numbers, we usually call intersection. Intersection, where they meet, where they intersect. So then it's represented by the symbol N, just like N. And then the union is represented by the symbol U. So now let's try a question and see. In the question we have set A represents multiples of 4 less than 20. So if you do remember, what are multiples? So multiples of 4, we have 4, 8, 12, 16. Because the question said less than 20, so it should not be up to 20. Then B also contains even numbers less than 20. Now let's list even numbers. You remember 2, 4, 6, 8, 10, 12, 14, 16, 18. Less than 20, so 20 is not included. Now if you want to look for the common numbers, the intersection between A and B, as the question says, find A intersection B. You're going to have, is 4 here in A and B? Yes. So 4 is here. You write 4 there. Now let's go to 8. We have 8 there as well. So 8 is here, 8 is there. We have 12 there, 12 is here, and 12 is there. Do you have 16? 16 is here, 16 is there. Now there are no numbers in A, so there can't be any intersection between A and B. So the A intersection B is simply 4, 8, 12, and 16. Now question 2. Set A contains prime numbers below 30. Set B contains odd numbers less than 30. Let us try to identify them. So let me solve it here. Now set A contains numbers less than, prime numbers less than 30. So prime numbers less than them, if you do remember, we have 2, we have 3, we have 5, we have 7. 9 is not a prime number, so we move to 11. We have 13. We have 17. We have 19. We have 23. We have 29. Now let's consider odd numbers less than 30. So set B has odd numbers less than 30, and then they are, that's going to be a lot. So 1, 3, 5, 7, 9, 11, 13, 15. But please, if you are writing these, please make sure you put the commas. I don't want to add the comments to make my work so tedious. 19, 21, 23, 25, 27, 29. Okay, so we now have the values for set A and set B. Now the question I is find A intersection B. So what numbers are in A and in B at the same time? So let's say we have 2 in A. Do you have 2 in B? No. So A is 2. A 2 is not part. We have 3 here and we have 3 there. So 3 is part of it. So the first is 3. Now we have 5. We have 5 here as well. So we have 5 and 5. So 5 comes. We have 7. Also have 7 here. So the next number 7. We have 11. Do you have 11 there as well? Okay, so here is 11. We have 13. 13. So please be listening to them. I'm giving you a guide. We have 17 here, 17 there. We have 19 here, 19 there. We have 23 here, 23 there. We have 29 here, and we have 29 there. So you can continue the list as now that the values would be for A intersection B. Now next, if you want to find the union, it's going to be A union B, and that's going to add all the numbers between A and B. And that's it begins from for A union B. The values are going to be, I'm going to list all for you, so please 1, because 1 is in B. Then let's see 2. 2 would come. Then 3 would follow. Then from 3, the least number there was 5, so 5 would continue. Then 7. Now it would be going to be like this. So put all the numbers there together. Alright, so the next is Venn diagram. I think at this point the video is getting too long, so I'm going to pause here and do the next video for you very soon. So we're going to start from this very Venn diagram. I'm sure it's okay. If you have any question, you can put on a page and we will address it. Thank you so much.